like to start that. All right, so I'm going to start off with doing an introduction to the Pan-African Robotics Competition. The acronym is PARC. The goal for PARC is to inspire STEM in Africa. PARC started in 2016. I think it's 2015. And since then, we've had over 1,000 participating students all across the continent from over 30 plus countries. Every year, we organize competitions for middle school through to from middle school through to university and even graduate professionals. We design competition tasks and in the area of robotics that people from different backgrounds can participate in. So it's been a wonderful experience. Right now, we are running a competition that started in March, and I'll talk a little bit more about that. Okay, so if you're interested in PARC and you'd like to participate in PARC competition in the future, we have much more information in the website, the PARC website, but you can also reach out to me, or we can hook you up for the future. All right, but for this year, the Engineers League is the component of PARC that focuses on university students and graduates. Okay, so these are people who are aspiring engineers or already engineers. And this year, we have teams from 60 teams from about 22 countries. Okay, and the image that we have on the screen just shows the different countries that are represented in our PARC cohort this year. So it's very exciting to see the spread that we have for PARC. And the goal that we have is to inspire more and more people to practice robotics on the continent. And that way move us more and more forward to benefit from the great opportunities that we have in robotics and automation in Africa. All right. The theme for this year is on agricultural technology. And I'll not go into too much detail, but it is around having the teams design solutions to what we consider fundamental agricultural challenges or tasks, such as weed detection using computer vision, or navigating in a farm using a mobile robot to be able to do spraying or seeding or plowing, different things. All right, so it's very exciting. We're about a month into the competition and the teams are doing great work. All right. So now I would like to actually move us over to our panel discussion. I'll start off with just introducing, or having the panelists introduce themselves. And then we would go into discussions and Q&A. All right, so I will be the moderator. My name is Kenichukwu Mbanisi. You can call me Kene. And along with me is Aja, who is our language interpreter in French. we have 6 panelists, I believe most of whom are on the call. We might maybe not have 1 or 2, but we would work with whoever we have on the call. All right. So I know that Dr. Chinwe is here, so we'll start over with you. And then I'll cycle us through.
Thank you. Can you allow me to share my screen?
Yes, give me 1 minute. All right, I think you should be able to now. And just to do a quick check that you are on the English channel so that people can. All right.
Okay, so I looked through the panelists and realized I'm the only academic. Probably that's why I was thinking about getting the slides. So my apologies, I just felt it to help me really introduce myself better. Okay, so I'm Chinwe, and I did my BSc at Covenant University in Nigeria, and I also did an MSc there. And my BSc, MSc was in computer science. So my journey really began in my final year when my PhD advisor came to Covenant University to give a talk. And I was really intrigued because she does research in robotics, but then she was coming to give a talk in computational biology. So it was a very interesting mix. So I had a discussion with her, and she told me to basically apply and come to Texas A&M to do my PhD. So I began at Covenant University, and then from there.
But Chair, can you just hold on 1 minute? I'm not sure are we having audio issues? Can other people hear the audio? Sounds like Erica is having trouble hearing.
Well, I can hear her clearly.
Okay, other people can hear. All right, that's Chinwe, can you just confirm what channel you're on in the interpretation icon?
I believe I'm in the.
Can you click on the English?
Okay. Can you all hear me now?
Okay, so Erica can hear now. Can other people also still hear? All right, good. Okay. And Adra, can you hear in French? Because that's important so that you can translate. You can. All right. All right. And also just Dr. can you speak a little slowly? It's a little slow. You can just have pauses intermittently so that it's easier to translate. All right, great. Awesome. Please go ahead.
So the interesting thing is I thought I was speaking very slowly.
Well, I guess it could be slower then, hopefully. Okay. But you were doing good. You're doing good. All
right. So I've talked about Covenant University, where I basically began my academic journey. From there, I basically, after having my talk with my advisor, I moved to Texas A&M. So my advisor is here. Her name is Nancy Amato. And so I spent some time doing my PhD with Nancy. So everybody you have on the screen here were her PhD students. So that will give you an idea of how big the lab was. And some of those faces here have gone on to do really wonderful things in the field of robotics. They are basically pace setters in different aspects in robotics. So I was fortunate to be in her lab. So in her lab, I did a lot of research in robotics, mainly the software side of things. So I was working more on building motion planning algorithms. So I wasn't into hardware building or even embedding. I was more into building the software and then having someone else do the embedding. And then I was doing more of the fundamental research in motion planning. And then I finished up my PhD. Then I moved to University at Albany in New York, where I currently am. And it's been a very interesting experience on so many fronts. So coming to a university and to a region that is very different from Texas was first a culture shock and then a people shock. The people on both ends of the spectrum in the US are very different. And then being a Nigerian and international was also a challenge. I will get into that when we begin to ask questions.
Right.
But then my research has evolved. So the thing about doing research and being in academia is your research evolves. So I was doing more of motion planning, the fundamentals of motion planning. When we say motion planning, it's basically how do you get your robots? How do you build algorithms and softwares for your robots to get from point A to point B? And how do you build a path for that robot? And so I've been at University at Albany, Albany, been doing motion planning. I've also been doing computational biology. I've started looking at adaptive motion planning. I'm beginning to inculcate machine learning systems, AI systems into robotics as well. So those are ways where I've basically made I've basically evolved in what I do. And then I'm very passionate about service initiatives. So that's the reason why I'm actually here today. So I was thinking this morning that in all my years as an academic, I haven't accepted any 9 a.m. Saturday meeting. So that gives you an idea of how important this is to me.
I appreciate
that. Yeah. So I'm very interested in giving back, in building what we have in Africa, really into equity initiatives. I do a lot of mentoring and a lot of STEM activities as well. So I'm going to just stop there and then we'll take up more questions and give you more about me as we go. Thank you.
Thank you very much, Dr. Chinwe. Thank you for being here this early in the morning. It's 9 o'clock. It was started at 9 o'clock where you are. Thank you. All right, so maybe we could have an intro of, let's see, Elijah, do you want to go next?
Sure.
So maybe I would please just make sure that you're on the English channel and the interpretation, and then yeah, I guess you can go ahead. You speaking?
Okay. Can you hear me?
Maybe a little louder, if possible.
Is it okay now?
Yes, it is. It is much better. Yes, it is much better.
Okay. Hello, everyone. I am Ocupualor Elijah, co-founder and CTO of PARC Robotics Limited here in Ghana. I hope I'm speaking slow enough.
Yes, go ahead.
Okay, so PARC Robotics, we are an agri-tech company that leverages cutting-edge robotics and then AI to improve crop production here in Ghana. I specialize more in PCB design. So yeah, electronics, anything with electronics and all that. So how I got here, I think it's mostly attributed from my experience, my previous experience. I think as at 12 years old, I was already considering myself as a farmer, planting maize, cassava, cocoa, plantain, and all that. And I love farming. Okay, so even though I love farming, there is still one thing that I find very challenging. That's it's a very stressful activity, you know. And because of that, a lot of the youth in my community, they've all moved into the urban areas in search of better jobs. And right now, I think as of 2021, I did a survey in my community. I realized that majority of the population now are individuals below 17 years of age, and the next in line are grown-ups, like the age people who are above 50 years. It's quite sad, and these old people are the ones taking care of farming activities and all that. Yeah, so I took it up upon myself to make a change. Change how things work there, make how I thought, how can I make agriculture, interesting and then also very lucrative to attract these youth to get more into that sector. So
I'm sorry,
basically, that's
Elijah,
how
if you
come.
just, hello, just 1 minute, sorry. It seems like our French interpreter cannot hear. Can you confirm that you're English, on the English channel?
Yes, I'm on English channel.
Okay. Aja, can you not hear? Can you maybe put in the chat if you're still not able to hear? You can now. Okay. All right. And okay, so Elijah, people were asking if you could speak louder. I agree. I think it was a little bit hard to hear your verbalization, and also maybe a little slowly as well. But I think most of what you've said came through. That's good. You don't need to repeat that, but maybe just a little more slowly
Okay.
and a bit louder. And
Okay.
yes, yes. All right. Yeah, the audio was a little bit muffled. I think that might have been the main issue, but I think that's all fine. And just one other comment. There are a few requests I'm getting about recording. Yes, this is being recorded and we will be uploading this online. So I I would I'm currently recording this. I will reject or deny the request for recording if you send it. I would be recording and uploading to YouTube and providing that publicly. All right. So please feel free to use it that way. All right. So Elijah, I'm sorry that I interrupted you. Go ahead. Again, just trying to speak a little louder and a little slower. And Aja, if you are not able to hear again, please put in the chat. Thank you.
Okay. I hope it's okay now.
Yes, that sounds much better. Yes.
All right. So once again, hello everyone. I am Ocupualor Elijah,
Oh, Elijah,
co-founder.
you don't need to repeat what you said. I think
Okay.
some of it came through. At least I think some of it came through. So you can just pretty much continue from where you started.
Yeah. So I think I was talking about how I got into robotics and AI. Yeah. So as at age 12, I was already considering myself as a farmer. I was already into maize, cassava, cocoa, what have you. And I was doing this with my grandparents. And as I mentioned earlier, most of the youth in my community consider this, myself as well, we consider this to be quite a stressful activity. So most of them have moved to the urban area in search of better jobs. And I took it upon myself to, make a difference, try and make farming or agriculture very interesting and then lucrative to attract this youth into that sector. So basically, that was my motivation or the drive that brought me here today. Yeah. I think I'll talk more about myself maybe in the Q&A session.
Very nice. Thank you. Thank you, Elijah. I'm very excited to hear more about the company and how that's going. Having a startup in robotics in Ghana is very exciting. Thank you for your introduction. All right, so maybe Dr. Olusola, we can have you go on next. I believe that you are here. All right, I can see you. Awesome. Let's do it.
Yes. Thank you very much, Ekenna, and it's my pleasure to be here. It's nice to meet wonderful panelists as well, and the audience, obviously, great audience as well. My name is Dr. Olusola Ayoola. I'm the founder of Robotics, and sorry, I forgot I was meant to be slow. All right, I'm so sorry. My name is Olusola Ayoola. I am the founder.
I just want to confirm that you're on the English channel.
Yes, I am on the English channel. Oh, well, let me choose quickly. All right, now I think I'm on the English.
You are. Okay, and please, all the panelists, if you could right now just go and make sure you're on English channel. I will just quickly move back so I can show you what I'm talking about here. If you see interpretation, you can choose English. All right, if you look down on your Zoom panel, you should see an icon saying interpretation. Maybe we can do that very quickly so that we can flow more smoothly. All right, thank you, Dr. Olusola. Please go ahead.
All right, thank you, Ekenna. Olusola Ayoola is the name. I happen to be the founder of Robotics and Artificial Intelligence Nigeria. You can call that RAIN. I am also a lecturer at the University of Ibadan, the first university in Nigeria, West Africa as well. I had my undergraduates there at the University of Ibadan, Nigeria, and then I had my master's degree at the University of Manchester, UK, where I also had my doctorate degree. And then it was during my undergraduates that I, of course, got into electrical electronics engineering, but I did not think I was going to become a robotics engineer. But when I wanted to go for masters, I thought to myself, education should be something that you can finish and have some hands-on skills. It's not all about the formula and the theories and the definitions. You must be able to solve a problem. And unfortunately, in Africa, our education is still developing. Hopefully it gets to the point where we can brag a lot about it. But right now I can say that we didn't have enough practicals to make me realize what I could do hands-on. So I decided to go for masters abroad. And I thought I should be going for masters deliberately to solve a problem, not just for the sake of the degree. So I thought of a problem that was, to my mind, was a very serious problem. And unfortunately, it wasn't a Nigerian problem, to be honest. I thought of a problem in the US because I felt I should be solving the next level problems, okay? Next level problems. And so I was looking at the problem of the underground tunnels that smugglers use in the US to smuggle, illegal things to the US. And so I thought, there's going to be need for some sensors that can actually scan underground as far down as, 50 meters, 10 meters on the ground, and be able to report that very quickly to the security agency. So I thought, you know what, I need to go for something in either telecommunications engineering or control systems engineering.
Slowly.
Sorry.
This is great. This is
so
great.
I got myself into control systems engineering, and that was how I began to look into how to solve problems, and I got that. My PhD was more interesting. It was particularly in the nuclear robotics field. Nuclear robotics, because UK has a lot of nuclear waste and humans cannot just go in there. So they needed to build robots that can go in there, even if the robots would just last 10 hours in a radioactive environment. So that was how my PhD led to my postdoc, at the University of Manchester, and I got myself deep into robotics. While I was doing my postdoc, I was also working with a robotics firm in the UK called PARC Engineering. But at some point, I thought it's not enough to just be somewhere abroad supporting a working system. Why not go to Nigeria and help others who are stuck in that system to get some practical knowledge? So I came down to Nigeria to do two things. Number one, to become a lecturer at the university. And number two, to set up my own space, the Robotics and Artificial Intelligence Nigeria, RAIN, where I also help people to develop their skills and also support companies in developing tech solutions for their business. So in a nutshell, that's what I've been up to for a while now. And I'm hoping that in the next 5 to 10 years, Africa will become the lead exporter of tech solutions globally, from robotics to AI to cybersecurity and all of that. Thank you.
That is a powerful vision, Dr. Olusola, and it's one that really gets me excited. Thank you so much. That was very wonderful. It's great to hear the wealth of experience that you have, and thank you for being here. Wonderful. All right, so maybe we can move on to our next panelist. Do you have Billy Okal? Are you on the call? It looks like you are.
Yes, I'm here.
Yes, awesome. Please just confirm that you're on the English channel on the interpretation.
Yes.
All right, awesome. And please go ahead and do a brief intro, share about your background, your career journey.
Yeah, sure. Yes, hi everyone. My name is Billy Okal. Right now I work at NVIDIA in the US as a staff robotics engineer. I'll talk more about what that means. Right now I work on two products, the NVIDIA Drive platform and NVIDIA Isaac Sim. So that spans autonomous driving and just general robotics. But to get here, it's a journey that started more than a decade ago. When I was doing my undergraduate studies back then in Germany, that's when I got into robotics. I started working as a research assistant at one of the German AI labs. And there, it just so happens that the tasks I was assigned to do was to do things related to robotics. So I was doing things like writing device drivers in Linux for like robot arms and drive systems for different robots. And that experience led me to be more and more interested in robotics, so that I was able to shift a few courses I took during my studies, like take some extra robotics classes, take some extra AI classes earlier on. And then this one thing led to another. I ended up doing internships only in robotics, continuing in the master's that was more specialized in machine learning and robotics, still in Germany, and then later spent some time at the University of Freiburg doing my PhD studies, working on using reinforcement learning to improve robot navigation. And at the end of that, I was fortunate to get headhunted, got a job offer that I could not refuse from there to come to the US to come and work at Apple special projects. So I moved over, worked there for about 2 years and some change. And then I also got another opportunity to join a startup that was just getting started called Voyage, which was doing something very interesting in autonomous driving. So I joined them, spent some time there. Almost 3 years, we did all kinds of work in autonomous driving. I was specializing in decision making. So this is the part that is in charge of doing things like deciding when should a car overtake or not, what should you do when you come to an intersection. So I was building algorithms for this. The company ended up getting acquired by another bigger startup called Cruise LLC, which, if you look at the news these days, is operating in San Francisco. So they have some of our IP and algorithms in that. And so when that happened, I moved on to try a slightly different world where I went to work for Shopify. They had this challenge that during COVID, everyone was ordering things online, and there's not enough manpower in the warehouses. They needed robotics to help with that problem. So I was managing a team there that is in charge of building software for a fleet of robots, something like 1,500 robots deployed across the US, Canada, and in the EU, which move items from the shelf to essentially the trucks that then bring the items to another warehouse or to you when you order something. I spent just over a year there and then moved over to NVIDIA, where right now I work primarily on Isaac Sim, which is a premier simulation software for robotics. And in the beginning, also worked on the Drive platform, which is NVIDIA's autonomous driving solution, which, if you look in the news, will be used to power some of the vehicles like Volvo and Mercedes since starting 2024. Yeah, that's a quick summary.
Thank you very much. Really, I have a fun fact that actually during my PhD work, I heavily used some of the work that you did using reinforcement learning for social navigation. I got your code from GitHub, and it was super helpful for me. So thank you for the great work that you did in your PhD and how that has contributed to research.
Thank you.
Awesome. I think, can we have Erica? Erica, you're here, I'm sure. So Erica, could you introduce yourself and share a little bit about your careers journey?
Yes, can you hear me?
Yes, yes, we can.
Okay, great. So I'm going to try to speak slowly. My name is Erica Adu, and I currently live in Boston, although I come from Nigeria. A little bit about my career journey to where I am currently at Amazon Robotics. I kicked off my interest in just general engineering through my upbringing in the Middle East, specifically in Dubai. And if you know anything about Dubai, there are a lot of very cool and exciting buildings and architectures. And that just generally got me interested in the, actually slightly unrelated, in the field of civil engineering, which I thought would be if I were to pursue studies in civil engineering, I would thought it'd be a great opportunity to contribute to constructing buildings that I grew up with and I was very fascinated by. And then I ended up going to the University of Pennsylvania in the US, where I studied mechanical engineering because I thought that would be a great opportunity to more broadly learn about a number of different engineering disciplines within one, because mechanical engineering does tend to be quite a broad engineering discipline. At Penn, I ended up getting excited by robotics. Penn has a pretty vibrant robotics program, and I had a number of not coworkers, but co-students that were also interested in robotics. And so I had the opportunity to take a number of different courses in robotics, courses in manipulation, courses in manipulation, courses in mechatronics, which gave me a good opportunity to get more involved in the realm of robotics. After my undergraduate in mechanical engineering, I ended up getting a master's degree in robotics, and was able to do some research here and there in the UPenn GRASP lab. After that, I graduated from my master's in robotics and ended up coming to work at Amazon Robotics, where I've been for the last 7 to 8 years. At Amazon Robotics, I actually started off as a mechanical engineer within the robotics realm. So I was doing a lot of mechanical design and not necessarily manufacturing, but design for manufacturing of the robotic drive units, which are essentially these ground robots. They drive around the warehouses of Amazon warehouses, and they pick up the shelves that contain items within the shelves, and then they move the shelves to people, and then people pick off the shelves and they fulfill the orders that people, I'm not sure where in the world Amazon is, but definitely it's in the US. People in the US receive outside of that, I think about 2 years into my tenure in Amazon Robotics, I realized I had, well, I always knew I had a passion for getting deeper into the robotic space, for getting deeper into research. And so I was able to build relationships as well as, leverage existing relationships, as well as work for additional teams while being on my current mechanical engineering team. And I ended up sort of in my free time almost joining the research team and contributing to the research team. And the research team focuses on item manipulation. And that is essentially how do we use robotic arms, not in a human exoskeleton sense, but more in an industrial sense. How do we use robotic arms in order to fulfill the orders that we have within an Amazon fulfillment center? Sorry, my husband is in the background if you can hear him. But yeah, so in an Amazon fulfillment center. And so within that team, I was able to specialize in specifically simulation and modeling. So I was able to leverage my hardware background as well as, bridge it with some software abilities that I gained in my master's degree in robotics. And kind of bring those two things together in order to contribute to the research team that I was on. So I found myself specializing in simulation and modeling. And what that looks like is sometimes that could look like a very physics-based simulation where we're using physics and simulation to be able to model our manipulation platforms and be able to I guess, accelerate real life development by doing things in simulation first. So designing algorithms, machine learning algorithms, computer vision algorithms in simulation. But sometimes that can look like answering high level business questions where you create a more generalized simulation, less specific, less physics based. And then you use that generalized simulation to answer more high-level systems questions. Then you write papers about it and you present it to the higher-ups and they make decisions.
Awesome. Thank you, Erica. That was really exciting background that you shared. Thank you. This is great. There's so many questions I have to dig deeper into all of these conversations. I think we have one more. I don't know if Emmanuel is on the call. We'll see. Emmanuel, are you on the call? Emmanuel, are you on the call? Perhaps not. All right. Okay, so this is great. There's so many directions I want us to go with. Thank you, panelists, for the great introductions. If it is possible, I would like us to actually move away from, I think maybe I'll keep sharing my screen, but if I could have the panelists just put on your videos so you could actually get spotlighted, and so we can actually see us having the conversation. It's going to be hopefully as interactive as possible. I would ask questions and maybe I could hint, maybe asking to particular people or maybe a group of people to get their perspective. And I will remember to speak slowly myself. And then we would have, if you would like to comment on a question that maybe was asked to somebody else, you could do so as well. All right, I'll actually try and see if I can stop sharing. Maybe this is maybe better. Okay. All right, just give me one moment. Let me reorganize this. All right, so there are a few themes that I want us to touch on. Again, attendees, please feel free to ask your questions, put it in the chat, and I will bring them up in our conversation. All right, the first theme that I want us to talk about is opportunities for robotics application in Africa today. Okay, and I'd like to maybe start off by asking Dr. Olusola, Elijah, maybe Billy, and anyone else who wants to chime in, that where do we see, what sectors do we see ripe application for robotics today? And this question is loaded because, in a sense, Dr. Olusola, you already mentioned that it could be hard to find technology market fit where there's a ripe market for technology that's advanced in robotics. When I was trying to get into robotics, I was trying to get my lecturers to provide recommendation letters for me. One of the things they said is, where are you going to apply robotics in Nigeria? And so that's a reasonable question. And so I'd like us to maybe talk about what are the opportunities for robotics application in Africa today? What sectors are most ripe, and where can we find some good technology market fit?
Thank you very much, Kenny, for that question. So at the time when I was when I was to choose what to do in masters, I, of course, saw robotics from a distance. And so at that level, I thought, well, to build a robot, you're going to have to be one of those big giant companies, and to do that, you're going to have to spend a lot of money. You're going to need to sell it at a very high price. But having obtained that knowledge now, it's interesting to note that you can build a robot in a laboratory. Like if you have a simple workspace, you can build a robot. You could build a simple vacuum cleaning robot. You could build an exoskeleton for those who are, those who are struggling with their upper limbs, to help them out with that. You can build a robot for the healthcare and, of course, for the farms. And I will go into details shortly. So having obtained that knowledge, it's amazing that Africa seems to be the place where that is required greatly because, and I will use an example from the oil and gas sector. When you want to refine crude oil, you could do it by building a very giant refinery, or you could do it with modular refineries. But when you don't have the capital to start big, you can start small. And so the same thing with robotics. For simple, medium-scale enterprises that want to make their jobs or their works easier, they may not have the funds to build a very big automation industry, but they can build simple robots that can do this for them. For instance, medical doctor, physiotherapist actually, that has something regarding helping patients who seem to have some kind of posture imbalance and need some help to get them standing right and walking in the right posture again. They need some kind of shoe or footwear that can help the doctor to know remotely, while not being at home with the patient, to know what the patient's weight distribution across both legs is. So he needs some kind of shoe or a footwear that when the patient is standing at any point in time, he gets a feed that tells him how the weight is distributed. Now, that kind of project, you may not find it when you go on Amazon, but you can easily get it when you call up a robotics expert and say to the person, I need this kind of solution. And it's going to be something with one or two components in the laboratory can be built. Now, that's one market. Imagine how many more would need that. I know there are actually big machines that some other hospitals in other countries have to give them this kind of data. But then we're talking of either starting big or starting small. Same thing with the healthcare, with the agricultural sector. Many times people have talked about, smart farming.
Patient is asking for slower.
Okay.
Yes,
So,
you can have pauses. You can just try to
yes.
have pauses every sentence, so it's easier for them to. Yeah, please go ahead. Very
Okay.
interesting comments.
All right, thank you. Now, and I will end with this one. So in the farms, I mean, there is always a need for smart farming so that farmers can manage a large farm without having to have too many hands. And with the aid of systems that can help give a graphic image of the moisture content across the farm, or with the aid of sensors that can tell whether there are weeds at some points in the farm, or whether there are animals, pests, or and it takes a lot of knowledge in robotics to see how you can build something for that kind of large farm with little or no, I mean, with little funds, I would say. Critical problem again with the farming sector in Nigeria is security. And people have said drones might be able to do the job. But at the same time, I've seen projects in the area of helping to detect animals and giving out a kind of sound that might scare away one or two of these animals. Now, if that solution is available, the market is there, because many farmers have always been asking for solutions, but low-cost solutions. And that is where hands-on knowledge of robotics can help build such solutions. So I think the horizon is bright for anyone in robotics in Africa, because with robotics, you can solve big problems with little cost. Thank you.
Your last comment about, yes, their applications are there in healthcare, like you managed, and like you mentioned, developing maybe more the bespoke solutions for people. For prosthetics and whatnot, and then also in agriculture. I think one comment that you made that I want to elaborate on is low-cost solutions. Perhaps. Sorry, I just need to mute someone. Low-cost solutions and how perhaps that is the area that is crucial in thinking about how technology would fit in an African market. Elijah, I know that you are. Sorry, could you mute yourself? I'm not able to actually mute you. Sure. Please, everyone, please mute yourself so that we can have the audio come through well. All right, so I wanted to have maybe Elijah jump in and share a little bit about how you see opportunities for robotics in Africa, maybe focusing a bit more on what your company does, which is agriculture. What area of agriculture are you operating in? And what are the opportunities that you're seeing?
My company currently performing robotics. We are operating in the green space of agriculture. So when it comes to things like maize, millet, rice, beans, groundnut, etc. So the key role robotics and AI is playing in this aspect is precision
Audio is a
agriculture.
bit muffled again. Can you hear me?
Of
The audio.
okay, yes,
I
I
know you
can
have
hear
done
you.
something before.
Is it better now?
Not so much.
Yeah. When I turn off my audio, it becomes better. My
Oh, okay. So yeah, please feel free. Yeah, you can turn off your video at least for this. Yeah.
Is it okay now?
It is much better. Thank you.
Okay, so yeah, precision agriculture. Yes. So my company, as I said, we are operating in a green market. Yeah, and
when it comes to such a market, we are talking about seed planting, fertilizer application, all the way to harvesting. Okay, so and it all comes down to precision. With precision, we are able to cut down on a lot of things like cost, especially when it comes to something like applying fertilizers. With our systems, instead of spraying the whole land, we are looking at applying it to specific crops. So we're using computer vision, for instance, we are able to detect crops from weeds. So when we are applying the fertilizer, we know that, yeah, we are applying it on the crops, but not on the weeds. I hope you, yes. And apart from that, the weed as well, using robotics, we are able to eliminate these weeds from the fields. We are able to do a whole lot of tasks actually. So in the agri space, there's this huge demand. So far from our interactions with large crop production companies, they've shown more interest in what we are doing, and from our discussions with them, the market is ready and ripe. All they need is people or who come up with such solutions, and then they are ready to patronize. Yeah.
Very interesting. Very interesting. Yeah, I've only recently started following the work that your company does, and it's very fascinating to see how you're making progress. I have a quick question though about your product. Are you at R&D phase, or do you have a product that's on the market right now?
Okay, so we have an MVP which we piloted last year. We did some pilot programs last year on some of our partner farms, but currently we are currently developing robots that will be shipping onto the market hopefully in the last quarter of this year.
Wonderful, wonderful. I have a few more questions to ask you, but I want to just maybe hear from Billy if you have any perspectives on this conversation around what sectors, maybe from your experience in the work that you've maybe done with data science. Africa is part of your also very involved in, or just the other experiences you've had. What sectors are you seeing to be most ripe for applications in Africa?
Yeah, sure. Yeah, thanks. Sorry.
Well, go ahead, Billy.
Okay, yes, thanks for this question. This is something that I've been thinking a lot, very hard for the last, I guess, 15 years or so at least. So in my perspective, and also the perspective we take at Data Science Africa, is that the opportunities are abound, they are always there. And there's really nothing stopping us from using robotics technology. I say robotics technology because for me, robotics is a collection of technologies. It's not one thing. And you don't have to use all of the robotics technologies to solve one problem. So for me, the way I think of it is, okay, so you have a problem that is locked with some specific local context. You properly define that problem, which may mean you talk to some domain expert that is not in robotics, like a farmer or someone in logistics, and they properly define the problem. And then you find out that I need 2, 3 technologies from robotics, one thing from another field, and then you solve that problem, like a very engineering approach. And so this is what I've seen done. I'll just give 2 examples. A few years ago, I spent some time in Ghana at Ashesi University with I have a friend there who teaches actually a robotics class there. And she had a student who wanted to do something about the transportation problem. So to move from Accra to Ashesi, it's a very uneven road. So if you go on Google to estimate the time to go there, the time is very optimistic, but because the road is bad and all these things, it's a very wrong answer. So we said, how can we solve this problem using something in robotics? So we did something small with just take a mobile phone, which somebody already has, because a mobile phone has accelerometers, which is a very decent IMU, inertial measurement unit, strap in a few of them on a standard car, drive it on that road a few times so we can get measurements of just the vibrations, how the vehicle is shaking and all these things. And then we could do signal processing to really understand where in the road there's a problem, so we can better improve this prediction, and we can also do better things like predict for you which road you should take, which route you should take to better save your car. So that's a very locally relevant application of some very advanced robotics technology, really nailed down to exactly what is relevant for the local problem. Because I always think that when trying to solve some of the problems in Africa, sometimes people try to damp down the technology, but I think we should not be damping down anything. In fact, we need the most advanced technology. We just need it to be applied in a very locally relevant context. Another example is right now I'm co-supervising a master's student in Kenya, where the Kenya Forestry Service came to us. So we don't know anything about trees, but the Forestry Service has people who are experts on trees. And they're doing all this work to plant new trees, reforestation, which then contribute to everything with climate change. You don't have to go there. So they're saying they're planting new trees, but they don't have a robust way of monitoring the growth of these new trees. They don't have enough manpower to go keep walking every time to go and check which trees are growing well, which ones have died, and all these things. So they came to us, so we have the student build a rig, which he 3D printed locally of a stereo camera system, which can be strapped on somebody's chest. And then the student can walk through the forest, take video pictures. Then we process this thing, generate depth imagery, and then from there we can detect the diameter of trees, the height of trees, and then from there, because we have the expert in forestry with us, they can give us the science to go from those measurements to say something about the tree, about the species, the health, and all those things. So this provides a solution that is relevant today using a cutting edge technology today. So we are able to use some of the segmentation models that you see published, months ago to solve something that is very relevant. So going back to sort of opportunities, I think for me, the thing that matters is if it's about defining the problem and scoping it so that the scope is not too big and overwhelming. And then once the scope is very well defined, you'll find that today, because software is very ubiquitous, simulation is getting more and more available, you're able to build a solution that is very locally relevant. And even if you go to other areas of robotics, like industrial robots, like if you go to any African country today that does some element of manufacturing, there are industrial robots in those factories doing things. The challenge you often find is that if one of those robots breaks down, an expert has to be flown in from another country to come and fix it. Right. So, but that's something that should not need to be. Our local universities should be able to teach the skills needed to do this without even having the robot. We could do this in simulation these days, and then go do practical internships at the local companies to learn the skills, and then from there we're able to apply these things more and more in local context.
Right. Thank you, Billy. Really great points there around defining the problem and scoping it, and then considering how robotics technologies interfaces with other emerging technologies to solve problems, and then also really relying on domain experts. I think those are great comments. As engineers, sometimes we could tend to think that we are the experts in everything, and not rely on domain experts that could provide the both cultural but even industry context to help our solutions be viable. I think those are great comments, and I think you touched on something else that I want to spare a conversation to, but I'll actually like to have maybe Dr. Chinwe and Erica, if you have comments around opportunities, but I really want both of you to also talk about what are some of the skills and abilities that are crucial for engineers to thrive in the field of robotics. Right, we're talking about how there are opportunities in the space, but one of the things that I think Billy started to talk about was technical depth and the availability of people with technical background. And I think that's an interesting thing that a lot of people here I want to hear about is, what are some of the skills and qualities that you need to build and develop to be successful in this field? Chinwe, do you want to go first? Yes.
Okay, I wasn't sure if I should go. So probably piggyback off what Billy said, what he ended with, when he talked about the local universities beginning to take the initiative. What do I mean by that? If you're talking about technical skills, a simple answer is STEM. So that's the basic technical skills that you actually need. So it's the same technical skills you would need to go into computer science, the same technical skills you need to go into mech engine or anything, basically. But then we need an awareness of the curriculum of robotics. So the curriculum is something that can be taught in every university. You don't need a big lab that has physical robots to actually teach robotics. So that's the fundamental issue that we need to begin to figure out how to solve. So if, for example, I know in Asheshi, they do some robotics, they have some robotics curriculum. And that's because Ayoola is basically there. And then we know in CMU Rwanda basically do some robotics as well, because there are some, David is basically there. So how do we spread this across Africa, where it's just like the way it is on this side of the world, where it's the norm? There's always a robotics course somewhere. How do we now inculcate that consciousness into the universities back home? Because you could have your robotics taught fully in simulation. And then that now gets that interest. So you do an undergraduate in robotics, which is just pure simulation. The interest is there, and then you travel out to do a master's, and you're looking at some big lab you want to basically test it, while we still work on the groundwork to build up what we have in Africa. So I don't have an answer to it, but it's something we need to begin to, in our consciousness, figure out how to introduce that curriculum.
Right. I mean, I think that's absolutely right. In my view, it's an emerging area of, I would say it's an emerging area of education on the African continent. There are more and more schools, universities that are offering robotics or robotics-related programs or courses, but I agree with you that the number is very low. And in our experience in the Pan-African Robotics Competition, we struggle to find teams that have all of the backgrounds that are relevant to really do robotics. And that's really the goal that we have for the competition, is to help to bridge that gap to some degree. The students are not getting the background from their schools, and so maybe there's a way that we could have place to fill in our cases, through this competition and workshops that we run during the competition. Erica, I'm curious to hear, though, maybe more specifically around what skills, maybe taught through school or through self-learning, are relevant to be proficient in the field of robotics, to be a roboticist. And so for people who are interested to grow and learn either through school or Udemy or Coursera, I know, what should we be looking at? Or how should we, what are some of the skills or qualities that we can aspire to building to succeed in robotics?
Yeah, so yeah, glad to answer that. A quick question, most of the people on the call, what's their level? Is it like undergraduate and graduate, or?
Very broad audience, very broad backgrounds. But I think it would be fine for you to maybe speak to young people who are maybe in university or graduates who are interested in exploring robotics.
Yeah, for sure. Yeah, so one thing that I think one of the panelists mentioned this, but one thing that I think is very interesting about the field of robotics is that it's pretty interdisciplinary. It's the combination of hardware knowledge where you're actually using your kind of more hands-on knowledge and understanding of the physical space and the physical environment to be able to build something. But there's also, software knowledge. Can you program in a number of different programming languages? Maybe you just have one that you're very proficient in, and that's enough. And then there's also electrical, where you understand circuits and electricity, and you're able to program, microcontrollers and so on and so forth. So I think that one thing about robotics is that it is very interdisciplinary. Do you have to be a master in all three? Not necessarily. I'm definitely not a master in all three, but I do have a basic understanding of each of the three disciplines and an aptitude to learn and be glad to be exposed to each of the three disciplines. So, as Billy mentioned, with the IMU that was placed in on those roads, that required, the IMU is a sensing equipment. So that's a little bit of electronics knowledge, but then they also had to program that IMU to understand all the different signals and so on and so forth to be able to get information from that. So there is an element of software involved there, but also they had to, I'm sure they had to mount the IMU somewhere. I know it existed in a phone, but they had to think, where do we mount this in an accurate enough location? So that's a little bit of hardware oriented knowledge there, and applied in a very advanced context, but you have to have an understanding of all three disciplines to be able to really flourish in that specific problem that he described. And that's the majority of robotics problems. Specifically within the realm of each of these, I will, I agree with what Chinwe said, where there's a good amount of, there's been a recent blow up in simulation in the last maybe decade or so, where there is the opportunity to do a good amount of learning in simulation. I would say it's also really important to couple that with hands-on experience. And, hands-on experience doesn't necessarily have to be as Chinwe is saying, doesn't necessarily have to be a, humanoid robot that is super advanced in a lab somewhere. It could be, the IMU that is in your phone that Billy was mentioning, that you use to be able to do some hands-on work in the realm of robotics. Or it could be, you grab a bunch of, I've had projects before that I've worked on where I've just gotten wood from somewhere, and then some small PCB, so a perf board which contains electronics and some wires, and I've hooked them up together and then built what is a robot, because it is hardware, software, and electronics all together. It doesn't have to be a very complicated piece of equipment. It's just a piece of equipment that autonomously can do things once you program it. And so that's what I would say. If I were to go more foundational than that, so something that is even more foundational is the ability to identify a problem and have the the like a problem solving mentality to be able to identify it and then solve it. So I'm going to go back to, you know, Billy's example of the problem that they identified, where they're like, oh my goodness, we need to be able to traverse this region and know how long that will take. And then they thought about, how do we solve this? What do we have that's available? What equipment do we have? You know, what would we need to do? And then they applied a number of different concepts and solved that problem. And I think that's pretty important generally in engineering, but definitely in robotics.
Awesome. Thank you, Erica. So I'm hearing, yeah, I think you bring up a really good point about robotics being interdisciplinary. And one way I like to think about it, and you mentioned, is robotics sits on a three-legged stool, where one of them is essentially computer science, the other is mechanical engineering, and the last is electrical, maybe more specifically embedded systems. Right. And so for the audience, if you're oriented in any of these directions, you can and really explore robotics, right? From an embedded systems perspective, or from a software perspective, or from a mechanical engineering perspective. So those are really great points, Erica. I have a follow-on question for that for you, to give some insights to the audience. Can you just briefly do a run through of a typical day for you, a typical day as a robotics engineer at Amazon Robotics? What do you do? Just to get a sense of, you know, what do robotics engineers do?
Yeah, I'd be glad to. I could describe 3 typical days. I will not go into a lot of depth in each of them, but just to show that it is an interdisciplinary discipline. I would say that, you know, a typical day, maybe just 2 years ago, would have been, I think someone asked a question in the chat about CAD. Sometimes that would look like I would be in CAD. So SolidWorks is a CAD software. Potentially I would be in CAD and I would be CATIA. That's another one. Someone mentioned that. I would not be in CATIA. I don't know CATIA, but some people do tend to be in CATIA. And that would look like, you know, coming up with a pretty quick design to be able to test something out. So I mentioned I do a lot of simulation. Sometimes we need to understand the gap between simulation and reality. So we need to traverse into the real world and design something to be able to validate the models we've created in simulation. So that would actually look like me being in CAD, even though I'm not necessarily a mechanical engineer anymore. I would still use that muscle of mine sometimes. However, a more typical day right now is I'll spend it in Python, which is a programming language. It's more of a scripting language, but it enables you to do a lot of you know, you can do machine learning in Python. You can do computer vision in Python. I don't do computer vision, but I do more machine learning in Python. And so sometimes I'll be thinking and I'll have a whiteboard either at home or at my desk at work, and I'll, you know, think about a number of different equations or a number of different scenarios that are relevant to the problem that I'm trying to solve. And then I will essentially program some things in Python. Either it will be an algorithm or it will be, I'll be analyzing some data. So maybe a lower level than that, less algorithms, more data analysis, and trying to use the combination of algorithms and data analysis to be able to solve a specific problem. Typically, the problems I solve are long-term problems. So I'm a research scientist. I'm not necessarily handed a problem on a given day and then I have to solve it. It's more of, I come up with a problem to solve. I survey the landscape, and then I get the next maybe 6 months or a year thinking about it and trying to solve it with this toolkit that I have.
Awesome, thank you. Interesting. Yeah, so you're more right now more the research side of things, as opposed to the not necessarily in the development track of robotics.
Yes, I'm very much in the research side. I have been in the development track in the past, and I'm happy to talk about a day in the life of a development person, but right now I'm more in the research space.
Thank you. Elijah, do you want to chime in, maybe just from your experience? What's what do you do when you're building a robotics company? What does that look like on a daily basis? What kind of things go into the work that you do, or the work that your colleagues do building robotics? I think for you in the area of agricultural robotics, just to give a sense for people to imagine what it means to be a robotics engineer.
Okay, so personally, I have a computer engineering background, but recently on an average day, I'm more of doing mechanical, electrical stuff. Yes, more of doing maybe metal cutting, designing 3D parts with CAD, as Erica said. Yes, so it's more of little bits and pieces of everything. So if I'm not doing hardware related stuff, I'm programming. That's me. I'm writing algorithms, I'm writing softwares to control these hardwares and all that. Yeah, so on a typical day, yeah, doing sometimes mechanical work, you move on to something software, you do something with electronics, and sometimes a lot of mathematics.
Interesting. Yeah, so I think just highlighting the fact that it's very interdisciplinary. You have to wear different hats, right, as you navigate
Yes.
in robotics. Interesting. Dr. Chinwe, do you want to talk a bit maybe about research? I know a lot, I think most of us here, one part or the other, hinted our journey involving getting an advanced degree in robotics, and that usually involves doing research to some degree. Can you talk a little bit about how people can think about robotics research, and maybe give some advice on opportunities or ways to align themselves towards opportunities to allow them to do robotics research, either on the continent or globally?
Okay, so robotics research. So now I did a PhD in robotics, but then you could get a master's in robotics as well. But then a typical research day is I call it tunnel vision. So you have an advisor, you have basically an area of interest that the advisor has. For example, I was doing research in motion planning. So my advisor was really interested in how do I begin to inculcate machine learning systems, machine learning adaptive systems into motion planning. So my research day would basically involve trying to understand what new machine learning tools would be able to solve this problem that I had. Mm-hmm. So that I could be considering, let's look at GAN, for example, looking at deep learning tools. So I could identify a particular tool that can naively solve a problem I'm considering. So I have some naive answer to the problem. Then I have to do the research of beginning to create something innovative, beginning to create something new, beginning to figure out how do I test. So you're going to be doing some testing in some controlled environment or in simulation. So there you're running your Python code, you're running your C++ codes, you're debugging. So in research, you're going to spend a lot of time debugging, and that's the truth. A lot of time you're going to be spent debugging your code. So there's all of that debugging, and then you have an idea, and then you run it through, and then you see some preliminary results. Then you run it to some more sophisticated physics-based simulator to get some results. And then you begin to publish. So I'm more on the academic side where we do fundamental research. So I'm trying to bring up this novel algorithm and then create some controlled experiment to test, and then I publish. So that's what a typical day would look like. So my PhD student, so the interest is I have a PhD student who just graduated, and his typical day started off that way. But the thing again, I as an advisor, I'm always looking for students who are innovative. So I always tell my PhD student that it gets to a stage where you know more than me, then I say you're ready to graduate. So beyond me giving you a topic or a direction, it's always exciting when they come up with new ideas. So my PhD students really started considering search-based systems, SLAM. He was going in a completely different direction from what I knew. I'm an emotion planner, basically. But he did SLAM, he did POMDP, he went that direction. And then he got to a stage where I had to buy robots because I was doing more simulation earlier on. So we got some robots, started testing on those robots. And then research also evolves. Or when I say evolves, it's interdisciplinary. So to get to a stage where you realize, oh, now I need computer vision. You don't do computer vision in an academic environment. You have to find someone who does computer vision to collaborate with. So we needed a computer vision expert. Then we had to find someone who could do computer vision. We collaborated with, had a paper, ran some experiments, and that was his final project for his PhD. So why am I saying all of this? There's no straight paths if you're looking at studying robotics, both in research, PhD, or in master's. It will evolve based on your interests and based on the expertise that you build along the way. Probably let me just stop there.
Thank you. Very interesting. Yes, there are many different ways to approach research in robotics. I'd like to maybe draw Dr. Olusola in. You lead RAIN, which I'm a big fan of, by the way. And I'd like to maybe just hear some of your thoughts around this topic. So just for some context, I think you mentioned this already, but RAIN trains robotics engineers, and maybe more broadly, artificial intelligence and robotics, right? And what are some of your perspectives on how just advice that you have for people interested in pursuing robotics? From your experience leading RAIN, what are some core technologies? What are some core skills? What are some core directions for learning? Can you give advice to?
Yes, thank you for asking that very important question. And I'm saying it's an important question because I had that problem when I graduated from the university. I wasn't sure what hands-on I could do. And, I had to go for a master's in a more, challenging environment like the UK before I could realize that the skills I now have can solve real life problems. You see, the thing is this, for anybody wanting to go into AI and robotics, they first must understand what problems they wish to solve. Because we have enough people who try to learn skills just for the sake of saying, oh, I'm a developer. Fine. You've learned how to use Python. You've learned how to use, if I go into the packages now, NumPy, Pandas, and Co. But what products can you build with that? What solution can you come on some time ago? And I said, with your knowledge of machine learning, in fact, I just said, with your knowledge of supervised learning, what problems can you solve just with supervised learning? And he struggled to come up with real life problems that can solve. So I think it's important to help people understand that, first of all, while you are about to start your journey, understand the sort of problems you should aim to solve. That way you can gauge your capacity. You can now know what you can do. You know how to market yourself. You would know how to communicate with those who should need your solution. Because those in the real world, when I say the real world, I mean the business class people, they may not know which discipline solves which problem. All they know is the problem that they have. And they don't know whether to call an engineer or to call a robotics engineer or an AI expert or something. But we are the ones to tell them that with what I've learned, I can solve this or that problem. So going into details, I will start by saying, there are many things that need to be learned in the course of trying to be an AI and robotics expert. Number one, very, very basic, but still very important, how to build applications, web applications, even if it's as basic as HTML, CSS. Because no matter what you do, even if it's a robot you build or an AI system, there has to be that interface where people can get to input commands and get to receive information from the system. Whether it's a web app or an Android app, an iOS app, you must learn to build it, or a desktop application. That's critical. In the past, at RAIN, when we used to teach robotics, we would simply teach them C++, and then later we teach them Python programming for computer vision, and then advanced things like that. But at the end, it's difficult for them to stand alone, because when you get a project, there must be that aspect of an interface, user experience. Then the real job is done by the C++ and the Python and so on. So it's important you learn basic desktop applications or web applications, how to build these things. Then secondly, API development, because we live in a world now of collaboration. You don't have to build the entire system. You might have the data. Somebody else might use the information for something else. For example, when you're building an autonomous robot, you might want to use information from Google. And it's interesting how Google has been putting an end to some APIs now. But then let's say they still have an API that tells you coordinate-wise how you need to move when you're going from a point to another point in your community. That API, you subscribe to it, you pay them for it. So that means that if someone else had an API that gives certain information, we will be able to market that. And that's something one can learn, especially if you are going to be in the area of AI. I am aware that Elijah has spoken about, smart farming, precision agriculture. And definitely from all of that experience, he may already have some data that he could share with others. And all he would need is an API running, and people can subscribe and get live data from his farm or something else. And that's important, and that comes together with cloud computing, because you must be able to be accessible globally, and you can use Amazon, cloud services, web services, or any of the other services that provide cloud computing, especially again, if you're struggling with capacity of your computer system. Again, Google Colab is there to help you process some of these programs. Then now the area of programming, it's funny how people say to me sometimes that Arduino is so basic, that no, we shouldn't learn Arduino, it's too basic, it's not for industries and so on. Well, it's still a very important step to take, to learn programming with Arduino, and then you can then complicate it a bit by learning the general C++ programming. Then of course, Python. In the past, I used to think I was never going to get interested in Python. I thought all I needed was C++. But it's amazing how Python has taken over my entire schedule now, because I feel it's a lot more convenient to program in Python. But hey, you can't program in only Python. You must program in C++ if you're a robotics person, because you need to program low-level control and of course the high-level side. But one thing many are probably not very firm with, which I think as a robotic expert, you must build yourself in that area, is having that kind of communication, or let me say interaction between between C++ and Python. I want to be able to have a robot vehicle that's coordinated by C++ and then have a server somewhere that is coordinated by Python, and then have them interact, which of course, I'm sure many of us here already know what that means. You either have serial communication or you have Wi-Fi communication, but then that's critical to understand how you can easily bring things together. ROS is there, Robot Operating System. And of course, many people are learning Robot Operating System at the moment. It's great. Looks like a community of helping all the programmers now to make sure whatever they build is compatible on ROS. I think it's a way to go. Then knowledge of sensors and actuators. Left to me, anyone who wants to be in robotics just needs to have knowledge of what sensors exist, what kinds of actuators exist. And then you'll be surprised how many problems you can solve just by knowing these things. But sometimes if you don't know what sensors exist in the market or what actuators exist, you might struggle to come up with how to solve problems. So it's important to have that exposure. And I'm saying all this because it's not a must that you go to a school that teaches all of these things. You might want to have your own training schedule where you think, today I must learn a new sensor or a new actuator and try things out on your own. Finally, I would say communication is critical now, especially in this area of drone technology, remote assistance and smart homes. Communication is key. Learning the various types of wireless communication, their advantages, and how you can improve them is key. In the area of drones, for example, there has been the need for drones that can travel long distances. And in many cases, the challenge would be, how do you stay in touch with your drone? Of course, there are many more challenges with drone technology, like the endurance and the noise and so on. But how do you stay in touch with your drone? One of them is satellite communication, which I'm sure is not very common here in this part of the world. So critically, we must look into how can we help get that communication thing done. If there's going to be collaboration with some other satellite communication companies, then that must start coming up in the meantime. And some people have to be experts in that area. About how my day goes as a robotics person, well, let me quickly say something funny. I hope it's funny to you. In the past, it used to be Stack Overflow and Gig for Gigs and co. But now it's just ChatGPT. All right, that brings everything to one place where you're like, okay, ChatGPT, how do I do this? And that means that some people have just lost their jobs. Those who could have been like junior developers who are supposed to assist with those little works, because ChatGPT does it very quickly for you, and it's handsome. But then apart from that, I'm also up and running with deliveries, picking deliveries from the gate. But I must say it's frustrating. In the UK, when I was in the UK, if you want something for your project, order for it today, maximum of 3 days, it will be at your door. But here in Nigeria, well, you have to wait for 3 weeks if you're buying from AliExpress. If you're buying from Amazon and you're going to pay for the high, the high delivery fees, then of course you probably will get it. And maybe, just maybe, there is a need for some kind of center in Africa that warehouses most of these things that we need. Why do we always have to request from China or the US when we can have, we are ready to start doing things, right? I think Amazon, okay, and I'm saying Amazon deliberately, should have a warehouse of virtually every tech device or tech component that we need so that it makes work faster. And I think that would help a lot of developers in this part of the world. For now, it's interesting that we really don't have much in that space. So basically that's about my view. I haven't mentioned 3D printing, but then 3D printing is critical in Nigeria today. Many people are making a lot of money from 3D printing. So you have a project, you come up with a design, all you do is send that design to someone in Nigeria. Most university students are into 3D printing already. They have it in their rooms. All they'll just do is print it for you and send it to you after you've paid, I think 15 naira per gram or something. But then that tells you that we are already in that space. Yes. Thank you.
Point. Very interesting. I feel like there are just so many things. You do like a laundry list of great skills and technologies that are important for people working in the robotics and related space. Very great. Thank you. I know people have some questions in the chat. I want to make sure that we get to the questions in the chat. There was one question about what are my chances in robotics if I'm proficient in CAD and CAM. I think hopefully that is clearer now to you. We've talked about how robotics broadly defined is interdisciplinary, and so if you're proficient in mechanical prototyping or in design, that is something that really comes into how you build mechanical systems for robotics. Right? Does anyone want to chime in very briefly? We're a little bit short on time, so maybe a very brief comment just to add to responding to Ifeanyi question around CAD and how, and what advice would you give to Ifeanyi? Maybe perhaps, you know, he can go beyond just CADing and learning more things, perhaps. Could be good advice. The other question is around how do you choose projects that people have registered in your platform? It's a little bit hard. If you could maybe explain further about that question. There are great comments around how mechatronics is growing in Africa, in Nigeria, very exciting news. That's great. Maybe a specific question here is how long will it take to have a robot functional for a particular task? That seems a little bit broadly defined. It might be hard to have a specific answer to that. Does anyone have a 1 minute response to that, perhaps?
Well, the answer is, so the answer is it varies. It can be as quick as weeks or years. It all depends on the task. So that's why it's important to be concrete about the task.
Right. Depends on the task. Yes, it's hard to say anything further than that, really. If you can maybe be more specific in your question, there could be more specific response.
And then there are some tasks that basically robots are not very efficient in. So yes, as Billy said.
Oh yes, thank you. There's a question I think really interesting for Erica. What advice do you have for a mechanical engineering undergraduate with a passion for system integration and robotics? Should they do a master's in robotics engineering?
Yeah, that's a good question. Yeah, so it definitely depends on your interest in further studies. I wouldn't recommend anyone do more studies than they are interested in doing. For example, I was very interested in research and was considering doing a PhD in order to get more into research, but then I realized I really wanted to work in industry, and I figured I could pick up the research skills as I went along within industry. And so I think that only do a degree if you are interested and passionate in that degree and not otherwise. So I'd ask you that question first. But then I would say that, yeah, if you currently have mechanical engineering skills and you feel you don't have much outside of specific traditional mechanical engineering skills, it would be very helpful to get further studies in robotics. Although if you don't have the resources to do it, there are also ways to learn outside of degrees. You know, I would teach myself stuff in the evenings when I'd come home from work. You know, there's Udemy, there's Coursera, there's just picking up your own independent projects and just sort of running with it. So, you know, you can always just buy an IMU or buy a microcontroller online and you know, just figure out how to program it by Googling and going on, or, you know, some of us go to ChatGPT or just a number of different means of learning. So I don't necessarily think that all learning has to take place within the realm of a degree. I think that if you are self-motivated and passionate and interested, you can learn outside of that context as well. So yeah, high level recommendation is if you're interested and it's something that's possible for you, go for it. But if not, I think you can definitely delve into robotics without that specific degree.
Awesome. Thank you. Thank you, Erica. And there was a follow-on question, I think more general, around any connection between robotics and sustainability. Does anyone want to take that for just maybe a 1 minute response to that question? Connection between robotics and sustainability.
Well, so robotics can and is being used to ensure sustainability in many industries, even starting from the obvious, like just manufacturing. By using robots to manufacture, you can save a lot on waste, emissions, and all kinds of things. And then it will save the company money, which then can be used to solve other problems with sustainability. So it's like it's a full cycle. But even more directly, projects in monitoring of the environment, like I talked about the forestry project, there's projects about like monitoring animals, roads, all those things.
Right.
Monitoring water levels so that you can predict when the droughts are coming and inform farmers. So all of that builds into sustainability.
Awesome. And
Yes, let
the question. Okay. Let me just make it brief.
just to add.
Yeah.
So in the area of sustainability, one thing robotics helps to do, for example, when you talk of sustainability, climate control, climate change action is one of those things we worry about. In the UK, there was a project that had to do with underwater robots, helping to check how many of plastics and some items were deposited in the sea, just to help clear those things. So in a way, with robotics, you can help to keep scanning the ground or the sea, underwater, to see what's happening. Are we helping the aquatic life, or are we damaging the aquatic life? As one of those things to worry about. And any other thing that has to do with carbon emissions monitoring, to be sure we're not releasing too much carbon within a particular space center, that would also help. And robotics can help to as well coordinate that kind of data collection for record purposes.
Awesome. Great. Just again, robotics, there are no robotics problems. There are problems that have robotics solutions, and usually not solely robotic solutions, but solutions that leverage robotics within a combination of other technologies. Right? And I think that's a helpful way to think about how we apply technology broadly. Sometimes as roboticists, we think our robotic solution is a hammer and everything is a robotics problem. It's not the case in real life. Great question from Irinze. Can anyone speak on the role governments in Africa should play in to help to bolster robotics and its adoption on the continent? Should there be a role for the government?
Well, in my opinion, there is a role for government. And the first role I think government should play is to make sure that there are resources available to people who are into this development. Take, for example, in Nigeria, I will use Nigeria as an example. We have this challenge I mentioned earlier about getting supplies. And at some point I think 2 years ago or 3 years ago, there was going to be some kind of collaboration with China to help the economy, but it turned out to be more of large projects, not looking into the areas of how we can fast track delivery between Nigeria and China for what we always try to buy. That's one. Secondly, NOTAB, that's a government agency that helps to promote technological acquisition. They have a job to play, they have a role to play in making sure that intellectual property of Nigerian developers is protected, and also to make sure that there is no brain drain. So when Nigerian experts, when a job is on ground, there has to be a Nigerian expert attached to those who are delivering on that job. So I think government must be very firm on things like this so that we don't lose the market in Nigeria. It's one thing to compete globally, but it's another thing when you're losing the battle at home already. So we must make sure that government tries to embrace solutions built by Nigerian developers and not rely more on those from outside or allow it to just go like that. It has to be something that if the solution is coming from the outside, it has to be in partnership with one or two developers, not investors, developers. That said, I think that government is trying. There is this new act called the Nigeria Startup Act, which has been passed at the federal level and is going to be domesticated in various states as time goes on. And that is an act by government to provide 10 billion naira, available to all developers at least to use. So hopefully that's going to help people with ideas start their idea. And when they get to a point where they can see it's going to be a great one, they can tap from that fund. We can only implore that government should make sure that they test people's ideas and not just give to anyone, but people that they are sure would go far That's it from my side.
Also, thank you for comment. What a role of curriculum, actually, yes. And so one thing that also came to my mind, how the government can play a part. Providing the framework for curricular innovation, so that universities have more access and have more of an interest to explore AI and robotics, funding for research, yes, and encouraging Africans to take on domestic problems. Very awesome comments. Thank you, sir. So I think, first of all, this has been wonderful, awesome. There's so many other directions I wanted us to explore, but definitely we did not with the time. Hopefully this has been informative for you. We're about 30 minutes off the time, actually, but I feel content with that to some degree. Hopefully you are too. I want to maybe all our panelists have a closing remark. And because I would like you to stick it to 1 minute, please, if you can, possibly, just a closing remark. And maybe pick, you can say, take your 1 minute in any direction you'd like, but maybe just focusing on having in your mind young people from Kenya, Nigeria, South Africa, Tunisia, who are really interested in, feel confused, not sure what robotics even means and how to play in this space, and don't have a lot of local support. What are just one word of advice or encouragement you could give to? Please, 1 minute, and I'll start with Erica.
Yeah, so probably some encouragement would be, I didn't really have much exposure to robotics until it was the end of my undergraduate degree, and now I'm working as a robotics scientist, and so it's never really too late to get into it. You don't necessarily have to be one of those people that was exposed in high school or even undergraduate degree. You can get into it at any point in your career, as long as you have the interest and the passion to explore and to learn in your own time, or even maybe pursue a degree in it, or if you can't do that, and learn in your own time. I also, another probably word of encouragement is, even if you don't have the degree necessarily for a position, you can still go after positions. And so I'm currently a research scientist, but most of the scientists I work with have PhDs, whereas I have a master's degree, but I was able to sort of, through just like working in my own time and reading things up and learning new and different skills, and challenging myself, was able to get to a position that was beyond what people with my degree normally get to. And so I think that education is very important, but I think you can also self-teach yourself a lot of different things. So that's probably just a good encouragement for other people here.
Thank you, Erica. Elijah next. Last words of encouragement to young people in Africa interested in robotics.
Okay, so for me, starting my journey in robotics, one of the challenges I faced was resources. Getting access to resources sometimes is very difficult. Sometimes too, depending on your level of education, you might not have the necessary resources, access to the necessary resources you need. They can look on to online courses or tutorials. They can check out Udemy and all those things. That's actually where I've been learning all these skills from. And again, as Dr. Ayoola said, sometimes getting access to electronic components can be very, very challenging, especially when you're buying something for $5 and shipping costs is like 3 or 5 times the cost of what you're buying. Sometimes discourages you. And if you're unlucky and you're living in a country where inflation is high every day, the dollar to whatever currency the exchange rate too can sometimes be. But anyways, what I do is I try and use simulations as much as possible. But of course, hands-on experience is also very necessary. So
Right.
Of course, the little components they have available, they should try and make use of that. And then, yeah, I think that's all I'll say for now.
That's great. That's great. Yes, I'm sure a lot of us have felt that pain point. Thank you for that encouragement. Billy, do you want to have a minute of encouragement and advice?
Yeah, sure. Piggyback on what's just been said, I would say start small, start from so understand what you have. If it's courses, like just been said, there's online courses these days. That's the good thing about the time we live in, from YouTube to specialized platforms. Take advantage of simulation when you can. Hardware access is hard, and sometimes it's tied to policy. But try to work with what you have. You don't need a full-fledged human robot to do something. So you can start with what you have. For example, or if your laptop has a camera, you can already use that before you go to a more fancy camera, for example. So I think that's how you get in it, because maybe you don't like computer vision, but you have access to a camera and do something in that, and that gives you the opportunity to now work in a setup where now you have access to do something with manipulation or navigation. So it's like you can always use one area as a stepping platform to go to the next. And like, for example, I've worked in almost every area of robotics, so you don't narrow focus to one area. Just be flexible in where you start and where you're going to end up.
Awesome. Being flexible and resourceful. Thank you very much, Billy. Dr. Chinwe, do you have 1 minute of encouragement or advice?
Yeah. So for some young people here who might be thinking, but I want to do a PhD. I want to come to a university this way to do a PhD. What do I need to do? So there are steps to it that most people think are difficult, but are actually very simple. One, you need to identify you need to identify professors that you're interested in working with and send an email. It's as simple as sending an email saying you're interested in doing research with them. And before you send the email, you need to do a research on them. So you're sending an email with information about what they do and where you want to fit in. And then if they're interested and you start having a discussion with them, they will let you know how to apply for a PhD or a master's to come work with them. And then in terms of what should your undergraduate degree look like, it can be as simple as just having a computer science degree or an electrical engineering degree. For as long as you have a degree and like a 2-1 and it's a good degree, just apply and reach out and send an email. It's as simple as that, and get the discussion going.
Thank you very much. Yes, that is very important advice. It could seem mysterious to people, but yes, actually it's pretty straightforward. Thank you for just highlighting that. And finally, Dr. Olusola, I need just 1 minute of encouragement or advice to young people interested in robotics.
All right, thank you. So the first step I would say to everyone who wants to get into that space is get the skill. You can get the skill by learning and practicals. Practicals, I must emphasize on practicals. You must have tried your hands on projects, starting and finishing, because many things you learn, many things you watch on YouTube about how people did something may not be the way it will turn out when you try. One of those on this, watching us here is David Nottage, one of my students, and he found out that building a face recognition for attendance registering system was not as straightforward when he needed to deploy it on a tablet. So sometimes you face the challenges and you will get to solve it. That's what they call experience. So it's one thing to have the skill to learn it, but it's another thing to have practiced it. Get the job done and then find a job. Now, I must say find a job, because many will tell me, well, there are no jobs. Yes, I deliberately said find a job, because I'm not saying that there are jobs out there, but I want you to create one. Okay, so if you can't find something, make something. And how do you make a job for yourself? You look around for problems. There are many problems. Like I said, the people that have those problems don't know who to call. But if you know that your skill can solve their problems, find those problems and meet those who have these problems and talk to them. One of the things I do a lot is speaking to experts in various fields. Like imagine you sit down with a psychologist or someone who is in that area of discipline, and they tell you exactly how they work. You can automate that process and build a solution that does the job for them. They could be your customers, or you could take their customers. Secondly, when you've solved these problems, you need to talk about these things on LinkedIn. LinkedIn is a powerful network system. That's probably how we were able to all come together in the first place. LinkedIn is powerful. You need to talk about what you're doing, because you might be solving a problem that somebody else is facing. And that's how you can make things work. Find collaborators, those who have one or two things that you would need or that can amplify the kind of work you're doing. And I must say also, find investors if you don't have the funds. But of course, you must have had a proof of concept. Find those who can actually invest in your ideas. And there are so many investors out there who just want people that can really, really solve problems. Not people with ideas, but people who have tested it. Learn how to pitch your ideas. The funds are out there, so you can all get big. And I'm saying again, we are all going to get big, so that in the next 5 to 10 years, Africa will be the major supplier of tech solutions globally. Thank you.
Thank you. This is wonderful. We have to speak a little bit, and we're not able to have a networking session, but I think that's okay. Hopefully what we could do is, if you're on LinkedIn, I have the post that we had on LinkedIn. We have all of the guests, panelists today linked out there, and so you can reach out to them. Our panelists, please accept connection requests so that you can have some of those connections with panel audience. If you have further questions, I'm sure you do, please forward those questions to the email I have in the chat. All right, and I just want to put one plug before we wrap up today. We have another panel session that would happen in 2 weeks, 2 Saturdays from today. That is on agricultural robotics. This is focusing really on agriculture. We have panelists that are people in agricultural tech space, people from the core agricultural industry who can speak to what are the problems, who are domain experts. If you're interested in agriculture or as an application for robotics or related technologies, I would encourage you to attend this. We'll be putting out the Zoom registration details this week. So please look out on LinkedIn or by email, however you got here today, look at that channel, the registration details. All right, thank you very much. Again, just a round of applause to our panelists. Thank you all so much. Hopefully this was encouraging to our attendees and guests, particularly those of you who are participating in the competition this year. I hope that you're encouraged and your horizon has been broadened. That's really the goal. I think, at least for me, is getting you to think more broadly, to connect you with more information to help you be more informed about what you can do and the vast opportunities that you have. So thank you so much, panelists. Again, thank you everyone for attending. We will be posting this recording on YouTube and sharing out the link. So feel free to rewatch and share with those you think would benefit. All right, it's been a wonderful morning, stroke afternoon or evening, wherever you are. Thank you again, and have a wonderful rest of your day. Thank you. Thank you all. Thank you.
Thanks a lot. Excellent.
Thank you all. Thank you, everyone. Thank you.